All right, I thought I'd do an example that dealt with an absolute value as the function. And so if you look, I've already kind of done this process. That was kind of to save time on this particular video. But if you have the limit as the absolute value of x minus 2 of the absolute value of x minus 2 as x tends towards -2, you can actually take -2, stick this for x and say -2 minus 2 is -4, and the absolute value of -4 is 4. So the limit should be 4. So, first four things we got to satisfy. One, is it a function? Yes. Two, do we have a c value? Yes, we do. So 2. 3, do we have a limit value? Yes, it's 4. 4, do we have an interval? Not specifically. So again, I use the plus or minus 1 rule. So we center around -2. We subtract 1 to get -3, and we add 1 to get -1. And so our interval is -2, -1. It's an open interval, and that includes endpoint. And the delta value in that case is 1. Okay, so we're told then that we must find delta, and to do so typically depends on the interval, function, and epsilon. All right, so we're going to use epsilon to find delta. And so our initial setup is as 0 must be less than the absolute value of x, and this would be plus 2 is less than delta, implies that 0 is less than the absolute value of the difference between the absolute value of x minus 2 and 4. And that has to be less than epsilon. Okay, so the first couple times we're going to take a look at this, or we're going to take a look at this a couple of different ways. But as you can see, we have a graph up here in the upper right corner, and this is about what it looks like. So we know that the limit exists, so we should be able to prove this fairly simple, or straightforward at least. However, the first thing we need to take a look at is this idea of the absolute value of x minus 2. Now, the absolute value of x minus 2 could be, and we want to remember, we want to make that small. So we want to make the thing inside small. So it could be two different things. It could be x minus 2, or it could be negative x minus 2. Okay, so if we have x minus 2, then we would have x minus 2 minus 4. That would be x minus 6. Or we could have a negative x plus 2, which would have a negative x minus 2. So that's a much smaller value. So we're going to choose that value. All right, so now, since I want to minimize that as much as possible, then I'm going to take negative x minus 2 minus 4, and that's going to give me less than epsilon. That in turn is going to give me the negative x plus 2 minus 4 less than epsilon, which will give me negative x minus 2 is less than epsilon. Now, don't forget that we have a proof of a theorem that allows us to move things or factor things from absolute values. So this proves the absolute value of -1, and the absolute value of x plus 2 is less than epsilon. The absolute value of -1 is just 1. Therefore, if we do it this way, then we have this setup here, which if we go back to the top is exactly what we're looking for delta. So in this case, we don't need anything. This just simply implies that delta is epsilon. Okay, so now we have delta. It's either epsilon or it's 1. And so we say delta is equal to the minimum of epsilon or 1. Okay, so we have to choose it, and that just depends on how small we make. All right, continuing on, we need to go back and show that this in fact does satisfy. So I'm going to take this one through as checked. Now, if we take a look at x plus 2 in our interval for being -1, and we compare that to x minus 2, you'll find that if you take a negative and add it to add 2 to it, you actually get a number that's less. So this would be -5, this would be -1. If we had -1, this would be +1. This would be, man, wow, brain fart. This would be -3. And so this one's always going to be less. And so if we know that x plus 2 is less than epsilon, but it's also greater than x minus 2, and so that means that x minus 2 is less than epsilon as well.